In 2006, the world witnessed one of the most controversial scientific decisions in modern history. Without warning, without ceremony, and with nothing more than a vote by a committee of astronomers, we erased a world from the map. For 76 years, Pluto had been our ninth planet, discovered in 1930 by a 23-year-old astronomer named Clyde Tombaugh, named partly after the Roman god of the underworld, and beloved by generations of schoolchildren who memorized it as the final, frozen guardian of our solar family. Then, in a single afternoon, the International Astronomical Union stripped it of that title. We called it a dwarf planet. We called it a rock. We called it debris. We essentially told Pluto, "You don't matter anymore." But here's what nobody warned us about. When we finally sent a camera to nearly 7 billion kilometers away, a journey that took almost a decade, to look upon what remained of this exiled world, the universe answered us in a language we were not prepared to hear. Scientists expected a silent, featureless ball of ice, a dead thing drifting alone in the dark. Instead, what the images revealed was something that defies logic, challenges our understanding of planetary science, and, if you sit with it long enough, begins to feel deeply, inexplicably unsettling. Floating mountains made of solid water, skies that weep a slow chemical rain, snow the color of dark blood, and at the center of it all a colossal pale heart, not a symbol of love, but a churning ocean of frozen poison, silently digesting everything it touches. Pluto is not dead. It never was. It is a frozen nightmare, beautiful, lethal, and stranger than anything science fiction has ever dared to imagine. And the real story of what we found at the edge of our solar system is only just beginning to be understood. To understand Pluto's isolation, to truly feel it, you have to attempt to comprehend the scale of the distance separating us. Imagine leaving Earth aboard the fastest spacecraft humanity has ever built. You are traveling at roughly 80,000 kilometers per hour, fast enough to circle the entire Earth in under half an hour. And yet you travel for 9.5 years before you arrive. In the early months, you watch the sun shrink. It goes from a blinding golden disk that fills the sky to something smaller, then smaller still. By the time you pass Mars, it's already noticeably diminished. By Jupiter, it is a brilliant point of white light. By Saturn, it is just one of the brighter stars. By the time you cross into the outer solar system, past Uranus, past Neptune, into the dark frontier known as the Kuiper Belt, the sun is almost indistinguishable from the thousands of other stars around it. Sunlight at Pluto's distance is roughly 1,000 times weaker than it is on Earth. Standing on Pluto's surface at high noon, the sky above you would not be blue. It would be absolute black, a permanent frozen twilight, silent and eternal. It was into this void that NASA's New Horizons probe finally plunged in July 2015. After traveling nearly 5 billion miles through the darkness, carrying instruments and cameras designed to pierce the mystery of the outer solar system, the spacecraft made its closest approach at a velocity of 14 kilometers per second, so fast that it had only moments to capture its images before rocketing past. What it captured changed everything. The first image to capture the world's attention showed something extraordinary. Stretching across Pluto's equatorial region, clearly visible even from thousands of kilometers away, was a shape so familiar and so impossible that it stopped people cold. A heart, a massive, bright, perfectly heart-shaped feature glowing pale against the darker surrounding terrain. The internet erupted. News outlets ran headlines calling it a cosmic love letter. People called it adorable. Social media was flooded with the image. But while the public melted, planetary scientists felt something colder, a deep, focused alarm, because they understood what that heart actually was. That feature, and officially named Sputnik Planitia, is not a message from the universe. It is an ancient impact crater, roughly 1,000 kilometers across, filled to the brim with one of the most chemically hostile substances in the outer solar system. The bright white color that makes it so distinctive is not snow as we know it. It is a vast, slowly churning glacial plain composed almost entirely of solid nitrogen, laced with frozen methane and carbon monoxide, compounds that would be lethal to any Earth-based biology. But here is the detail that truly shook the scientific community. Sputnik Planitia is alive. Deep within Pluto's core there exists a residual heat, the fading radioactive warmth left over from the planet's formation billions of years ago. This heat, though minimal, slowly rises through the interior, reaching the base of the nitrogen glacier. The warmth causes the nitrogen to become subtly, almost imperceptibly buoyant. It rises. It cools. it sinks again. Over and over in enormous convection cells, the glacier circulates, like an ocean of frozen poison set to an impossibly slow boil. The practical consequence of this is staggering. Sputnik Planitia is constantly renewing itself. Any meteorite that strikes its surface is not simply embedded in the ice. It is slowly consumed, dragged downward through the convection cycle, and eventually erased. The plane maintains its pristine white surface not despite the constant bombardment of space debris, but because it absorbs that bombardment. It digests it. Pluto does not bear the scars of its past. It devours them. If Sputnik Planitia is disturbing in its stillness, the terrain surrounding it is unsettling in motion. At the margins of the great nitrogen plain, enormous mountain ranges rise from the surface, peaks that reach over 3,000 meters in height, comparable to significant ranges on Earth. But these are not mountains made of granite or basalt. There is no rocky geology on Pluto's surface in the conventional sense. The rock of Pluto is water ice. At temperatures approaching 240 degrees Celsius, water ice does not behave the way we think of ice. It becomes rigid and dense, structurally comparable to steel in its tensile strength. The mountains of Pluto are essentially enormous formations of water ice rock, hard enough to maintain their towering peaks against the weak gravitational pull of the dwarf planet. But here is where physics delivers its most surreal twist. Water ice, even at these temperatures, is less dense than solid nitrogen. The floating glacier of Sputnik Planitia is heavier, by volume, than the mountains that border it. The physical consequence of this density difference is breathtaking. The mountain ranges along the coast of Sputnik Planitia are not anchored to any bedrock beneath the glacier. They are floating. Entire mountain ranges, structures thousands of meters tall and hundreds of kilometers long, drift slowly across the surface of the nitrogen sea, like colossal icebergs on an alien ocean. The landscape is not static. It never was. Over the geological timescales that govern Pluto's slow internal rhythms, these ranges have been moving, shifting, drifting, a continent of mountains in permanent, silent migration. If you stood at the shore of Sputnik Planitia and looked out toward the horizon, you would see those mountains slowly, almost imperceptibly, moving toward you. Look closely at those floating mountain peaks and you notice something that belongs more to nightmare than to science. The snow that coats the summits is not white. It is not gray. It is red. A deep, dark, arterial crimson, the exact color of dried blood. This phenomenon is not an illusion or a camera artifact. It is a real chemical process, triggered by the faint but persistent ultraviolet radiation from the distant sun. When UV light strikes the frozen methane on Pluto's surface, it breaks the molecular bonds and initiates a cascade of complex organic chemical reactions. The byproducts of these reactions are compounds called tholins, reddish-brown organic molecules that gradually accumulate on exposed surfaces. These tholins do not simply coat the rock, they fall from the sky. Pluto has a thin, tenuous atmosphere, barely more than a whisper of nitrogen and methane, and within that atmosphere, tholins form as haze particles and drift slowly downward, settling on the highest peaks first, staining them red before being buried by fresh deposits or swept aside by the glacial dynamics below. The sky above Pluto is not the black void you might expect. According to New Horizons' atmospheric data, when light scatters through the thin haze layers, Pluto's sky takes on a faint but unmistakable blue tint, hauntingly similar to Earth's own atmosphere, yet separated from us by a distance so vast it becomes almost philosophical. A blue sky, red snow, floating mountains, a poisonous white heart. Pluto is the most alien-looking world in the solar system, and it is one of ours. For decades, planetary scientists assumed Pluto was frozen all the way to its core, a solid ball of ice and rock, inert and cold, unchanged for billions of years. But the data from New Horizons revealed something that forced a fundamental rethinking. The numbers did not add up. The mass of nitrogen ice in Sputnik Planitia is enormous. Under Pluto's gravity, that mass should have exerted enough rotational torque to cause the entire planet to reorient, essentially tipping over on its axis, billions of years ago. That process, called true polar wander, should have repositioned the glacier long before now. But Sputnik Planitia sits almost exactly on Pluto's equator, in the precise location where rotational dynamics should pull a large, dense mass, which means that below the glacier, deep below the icy crust, there must be a counterweight, something massive keeping the system in gravitational balance. The only explanation consistent with all the data a subsurface liquid ocean. Scientists now believe that beneath Pluto's frozen shell, buried under perhaps 100 to 150 kilometers of solid ice, there exists a vast ocean of liquid water. This ocean is kept from freezing by two forces: the immense pressure of the ice above it, which lowers water's freezing point, and the residual radioactive heat from the planet's core, which provides just enough warmth to maintain liquid state. This ocean is in total darkness. It has never seen sunlight. It may have existed for billions of years, sealed beneath its ice ceiling, completely isolated from the universe above. And here is where the question that keeps astronomers awake at night enters the conversation. Where there is liquid water, there is the possibility of life. Not certainty, not probability, but possibility. And in science, that is enough to demand serious attention. We have found microbial life in the most extreme environments on Earth, in hydrothermal vents at crushing ocean depths, in the frozen rocks of Antarctica, in highly acidic and hypersaline lakes. If life can emerge and thrive in those conditions, the question of whether something might exist in Pluto's deep, dark ocean cannot be dismissed. We do not know. We may not know for generations, but what we do know is this. Beneath the surface of a world we once dismissed as irrelevant, there may be a body of liquid water larger than all of Earth's oceans combined, waiting in the dark. Pluto does not face its strange existence alone. Locked in a gravitational dance with it is Charon, its largest moon, and Charon is no ordinary satellite. It is so large relative to Pluto that the two bodies do not orbit each other in the conventional sense. Instead, they orbit a shared point in empty space between them, a binary system, two worlds in a mutual gravitational embrace, spinning together through the void. They are tidally locked to each other, meaning each always shows the same face to the other. If you stood on the side of Pluto facing Charon, the moon would hang permanently in the sky, enormous, unmoving, watching. It would never rise. It would never set. It would simply be there, always, in exactly the same position. On the opposite hemisphere of Pluto, Charon would never appear at all. Two faces of the same world, one eternally observed, one forever alone. Charon itself carries a mark of their connection. Its north pole is stained with a dark reddish patch, officially designated Mordor Macula, and the name feels accurate. This stain is composed of tholins, the same crimson organic compounds that redden Pluto's mountain snow. But Charon has no methane of its own. The tholins on Charon came from Pluto, gases that escaped Pluto's thin atmosphere, drifted across the 19,000 kilometers of space between the two worlds, and froze onto the cold polar cap of the moon. They share an atmosphere. They share a chemical signature. Two exiled worlds at the edge of the solar system, bleeding the same red into the darkness. We took Pluto's title. We voted it out of the planetary club and moved on, content to let it drift in obscurity. But Pluto didn't need our validation then, and it doesn't need it now. It is the undisputed king of the Kuiper Belt, a region of space beyond Neptune teeming with hundreds of thousands of icy bodies, the leftover debris from the formation of the solar system. Pluto is the largest, the most complex, and, as we now know, the most geologically active of all of them. Mountains that float, snow that falls red, a toxic white heart that beats with internal heat, a hidden ocean that may hold the conditions for life. Pluto will continue its slow, solitary journey around the sun, long after our own civilization has risen and fallen. Every 248 Earth years, it completes a single orbit, an orbit so elliptical that at its closest point it dips inside Neptune's path, and at its farthest, it retreats to nearly 50 times Earth's distance from the sun. It has been doing this since before the dinosaurs. It will be doing this long after we are gone. The beauty of Pluto is terrifying precisely because it reminds us of how little we truly know, not just about the outer solar system, but about the nature of worlds in general. We looked at Pluto and saw a small, cold, irrelevant rock. We were wrong in nearly every assumption we made. The universe corrected us with floating mountains, red snow, and an ocean buried beneath a kilometer of ice. What else are we wrong about? That is the question Pluto leaves us with. Not a message of love despite the heart-shaped glacier, but a reminder, silent, patient, ancient, that the cosmos does not conform to our expectations. It only ever surprises them. Keep looking up. Keep asking questions. The edge of what we know is always closer than we think, and just beyond it something extraordinary is waiting. If this journey to the frontier of the solar system fascinated you, share it with someone who loves astronomy and space science. What do you think? Should Pluto be reclassified as a planet? Or is it something entirely new that we don't yet have a category for? Drop your thoughts in the comments. See you on the next mission.